Hello guys, welcome back to my channel Algorithm Minds. My name is Azan Khurram and in this channel I teach programming skills in Python, MATLAB or R programming. I also teach theoretical concepts as well as practical programming skills in data analysis, statistical analysis or data science or machine learning. So if you are a person who wants to learn programming in like Python, MATLAB or R programming for beginning, or you are a person who wants to excel his career in data science, I request you to subscribe to my channel, hit the notification bell icon button because I will be posting a lot of videos related to these topics. So as I have stated earlier that I am going to produce a series of videos regarding statistical analysis in Python. So in today's lecture, we are going to discuss about population and sampling methods used Python. So we will discuss about the concepts of populations and we will discuss about different sampling methods we have, and we are going to implement that concept through the help of Python programming. So it will be a highly resourceful video. I request you to stick to the end and watch the complete video, so it will help you understand the concept as well as apply those concepts with the help of Python programming. So let's briefly discuss about population and sample. So a population refers to the entire group you want to draw conclusions about. It can include people, objects, events, organizations, country, species or any other elements relevant to your study. On the other hand, a sample is a specific subset of the population from which you collect data. For example, you have say a huge population and you have a data set that you termed as population, and it has entities in millions of rows. And now you want to take a sample out of that million entities that will ultimately represent and then you want to estimate some parameters like mean, some other parameters that will represent the population in the context. So the size of the sample is always smaller than the total population size. It represents a smaller manageable group that can be studied or draw inferences about the larger population. So the whole idea about the population and sample revolves around how we can actually take a sample out of a big population and draw some inferences about using that sample data, and that inference will ultimately project to the larger population data. That will actually help us understand about the population itself by drawing some smaller sample and doing conducting analysis on it, and that analysis the parameter estimation will help us understand the population as a whole. Understanding population and sample is crucial in statistical analysis because the characteristics of populations are often unknown or impractical to measure entirely. By studying a sample, we can make inferences or predictions about the populations. So let's briefly discuss about some examples in sampling and population. For example, consider a study aiming to estimate the average income of all adults in a country. The population would be all adults in the country, while the sample might be a randomly selected group of 1,000 individuals. Okay, so you get the idea here. So the population will be all adults in the country, while the sample will be the randomly selected 1,000 adults out of all that population. And another example could be a manufacturer testing the quality of the product by inspecting a sample of items from a larger production batch. The population would be all items produced, while the sample would be a subset of those items which are collected for sampling and testing. So enough with the theoretical aspects. Let's move on and actually apply those concepts with the help of Python programming. So in order to do that, I'm going to import two important libraries. The first one is actually the module in Python which is random, and the second one is the library NumPy. So we are going to import that module and that library NumPy by using this Python statement here: import random and import NumPy as np. Once we have imported our libraries, let's move on and discuss about different sampling techniques we have in statics and how we can actually implement those concepts by the help of Python programming. The first we are going to discuss about is random sampling. Random sampling is a sampling technique where each member of the population has an equal chance of being selected for the sample. It minimizes the bias and ensures that the sample is representative of the whole population. And how we can actually implement that method in Python. So we are going to, first of all, we are going to import an important library. We already have done that, so we are not going to import it again. So I'm just going to go comment it out. Now to generate, first of all, in order to create a sample from a population, we actually do need a population. So we are going to first create a population. Once we have created the population, then we can actually move on and further take the sample out of that population. So in order to create the population, I'm going to initialize a variable name population underscore data, and then I'm assigning it a value by calling the numpy library method rand integer. What it does, it actually creates some random numbers that has some whose range is actually from minimum value to the maximum value. And we can also specify how many numbers or population data we actually want. So I will discuss that method in detail right now. So we have this method rand integer int, and we are passing 3 input argument to that function. The first one is 1, then comma 10, then size is equal to 10,000. So the first one is actually the minimum range of that randomly generated values. Okay, so you have some range, specific range, and that randomly generated numbers will lie within those range. So for example, if I have a range of 1 to 4, so all those randomly generated variables or elements within that population data will have random values of 1, 2, 3 and 4. So 1 is the minimum value of the range where you actually want to start generate your random values. Then we have 10, which is exclusive. It means that this is again used for the maximum value of a range. As I will recall the example I have given you about 1, 2, 3, 4. But in that case, this 10 is exclusive. It means that it will not include 10. It will include value that is less than 10, that is 9. Okay, so this by using this input argument 1 and 10, I'm telling this Python statement that I want randomly generated values that lie between 1 to 10 minus 1, that is 9. Okay, so the values that have been generated will lie between 1 to 9. And then finally I'm defining the size. I want size is equal to 10,000. I want 10,000 randomly generated values that lie between 1 to 9. Okay, 10 being exclusive, so we say 1 to 9. So this is how you can actually generate your population data. Okay, once you have generated your population data, let's move on and actually discuss about our main concept here about sampling. So as you recall that we are talking about random sampling, where each element has the same equal chance or probability of being selected. So how we can actually do the random sampling? We are again going to use NumPy library, and within this NumPy library I'm going to use its method choice, which allows us to actually randomly pick value out of the population data. And I will pass 3 input arguments to that method function here. First of all, I will initialize or declare a variable name, then I'm going to assign its value by calling the method, and I'm then passing 3 input arguments: population, size, and replace is equal to false. So the first one is quite obvious. Okay, we want to generate randomly selected values out of what quantity? So we want it for population data. So I'm going to there's a slight mistake here. So it should be population data, the same variable as we will declare for the population. So the first one will be the population data, out of which we'll randomly select values. Then the second input argument is actually the size. What would be the size of the sample data? In our case, we want it to be just 100. So we assign its size is equal to 100. Then the last statement or the last input argument is replace is equal to false. By doing that, we will make sure that each element is only selected one time. It's not selected 2 times. So it will only any element that is selected by using this method will be only selected 1 time. So it will not be repeated. So that's what it actually does when we use replace is equal to false. Now you have done that, like you have actually created your population data, then you have actually created a sample by using random sampling by using this method choice. And then we are simply going to print those values. First I'm going to print some portion of the population data, then I'm going to print some portion of the sample data. So again I'm going to change the variable here from population to population data. Let me just run this code of block for you. So as you know that the population data has actually 10,000 values, so it just truncated the values within those ranges. But you can also see that concept here. We are told you that it will generate random values from 1 to 9. So you can actually see that the values are actually indeed within 1 to 9. Okay, and then it takes a sample that is randomly selected by using this method choice, and we are getting 100 values. Again, that will be from the same population data. In that case, they will also have 1 to 9 values. So you can say that we have generated a sample data. So that's it for random sampling. If you still have any question related to random sampling, feel free to write down your question in the comment section. I will be happy to help you out. So let's move on and let's discuss about systematic sampling, which is another form of sampling technique we are going to discuss. So systematic sampling involves selecting every nth member of the population after a random starting point. Okay, it is useful when the population is ordered in some way and it's more efficient than simple random sampling. So I'm going to explain you further about this concept by the help of Python programming. So let's move on and actually discuss about that. So as you recall that we have already formed a population data, which is the population we are actually taking samples from, as we have done earlier in this Python statement here. Now we are using a slicing method here, double colon then 100. In this slicing method we are defining, we want to pick values that are the 100th interval. Okay, so that's what it means by we are defining the interval here, that after every 100th interval where this single colon without any value represents that we want to start with 0, then we want to take the value that is present currently present at 100th index, then after that we will take the next value after another 100th interval, and then so on. For example, let's say we have started with 0, then we want to take value that is present at 100th index, then take another value that is present at 200 index. But keep that in mind, the here 100 is exclusive, so the value will start from 0 and the value will be taken from the index 99, then the next one will be actually 199. Okay, so that's how it is it. So we are taking values in a systematic way. Okay, the interval is a kind of a systematic in a way. So that's what we mean by systematic sampling. So once we have actually calculated the samples, we are simply going to print its value by using this print function. And now you can see I have printed the values for the systematic sample. So that's what we mean by systematic sampling, where we actually take values through some systematic means instead of randomly picking values. Now let's move on to a little more advanced concept in sampling, that is called stratified sampling. So stratified sampling involves dividing the population into subgroups that are called strata based on certain characteristics, then randomly select samples from each stratum. It ensures representation from each subgroup. And I'm going to explain you further this concept by the help of this example in Python programming section. And within the stratified sampling, we have two kinds of sampling. The first one is disproportionate sampling. The second one is proportionate sampling. So disproportionate sampling involves selecting unequal sample size from different subgroups or strata within a population. Okay. And then we have proportionate sampling. Proportionate sampling involves selecting sample size that are proportional to the size of different subgroups of strata within the population. So that's what we mean disproportionate sampling and proportionate sampling. Now I'm going to explain that concepts with the help of Python programming, so you will be able to better understand those concepts and grab an idea by the help of this Python exercise here. So first of all, I'm going to import our library. For this purpose, I'm going to import pandas library by using this Python statement, import pandas as PSD. Once you have imported your library, now I'm going to declare a data of population from where we actually want to take the sample out of it. And the population in our case is actually students from a class and their associated grades. So in that case, I'm in order to make a panda data frame, I first need to actually create the data in the form of dictionary. So here you can see that I have actually created a dictionary by using curly brackets, and within those curly brackets I have two key value pairs. And for those of you who don't have an idea about dictionary, like how to actually create dictionary, how to append values, I have made a dedicated video about dictionaries. I will put the link in the description for you, so you can actually go and watch that video. It's a highly resourceful video, so I suggest you, if you don't have an idea about how we can actually create dictionaries. So right now let's discuss about here. So in order to create data, I have created a dictionary, and that dictionary has two key value pairs. The first one is name, and then this associated value is actually a list of names for student. The second one is actually a grade, and its associated value is again a list of characters where each element represents the grade of the student. Once you have declared this dictionary, now we are going to call this class data frame of the panda library by calling pd.dataframe, and then pass the input argument our dictionary. This will actually convert this dictionary into a panda data frame. Once we have actually done that, what we are going to do, we are going to create a data frame group by object, which will actually allow us to perform the operation by groups, not by like elements wise. So in order to create that object, we will call this data frame df, then we apply the method group by, and then we will also highlight the column from where we actually want to group the values by. In our case, we want to actually group the values by grade, where we have like the categories A, B, and C, and so on. Okay, so we are going to use group by method. Then I'm going to assign the column name from where we actually want to group the values by. Then I am also using this another input argument, group key is equal to false. So the reason we actually do that is such that once you have actually created a data frame group by object by using this when you perform any functions to this data frame group by object, then the resultant data frame will have index of that values or the group they belong to. For example, the index will be, in our case, will be A, B, C. We don't want that. In order to avoid that, we will use this Python statement, Python input argument group keys is equal to false. Later I will show you the difference by changing this value to simply by removing this input argument and only leaving with the column name assignment. So once we have done that, let me just run this block of code for you. So now you can actually see that this group df test, or even the group df, is actually a data frame group by object. So now you have actually performed this operation. Let's move on and actually do a sampling. The first one is disproportionate sampling. The second one is actually proportionate sample, where we actually define like how much fraction of data we actually want out of that sampling technique. So in order to do that, you have to understand a simple analogy that we need to implement. So if you recall that we are first grouping the values by their respective categories, okay, by some sub characteristics. Then we are applying method at every group. Okay, so that's the analogy we need to understand once, if you want to actually understand this Python block of code here. So once you have done that, now I'm creating a function here, sample to students. Okay, because, and by the name of this function, it implies that we are taking sample out of a group, and we are taking two values out of that group. Okay, and this will take the input argument, the group, that we will pass it. Then it will return what? A group dot sample by using this sample method to identifies that we want to take only two elements out of that group, and random state is equal to 42. This input argument here actually help us for reproducibility. It will make sure that whenever the script is run again and again, it will produce the same results no matter how many times the script is run, because here we are actually dealing with random, where the values are being randomly selected. So it will make sure that every time the script is run, we will have the same results no matter how many times the scripts have been run. So by this method, we will randomly select two elements out of that group we have actually made by using this data frame group by object. Now you understand the functionality of this function. Now we are going to call this function, but not in a but in a specific way, and that specific way is called apply method here. So what does this apply method does? First of all, I will initialize a variable name disproportionate sample. Then I'm going to create a value by assigning a value by equating it to this Python statement here. I'm going to call my data frame group by object, that is group df. Then I'm going to use apply method. And what does apply method does? It will actually apply this function at every individual group. Okay, instead of applying this method to the whole group by, it actually applies it to the every individual group that has been created by this data frame group by object. And then I'm calling this function sample to students. Okay, so then this function will be applied to every individual group, and then finally we will have a single Panda data frame that will contain the sample that has been taken through stratified sampling. So you understand the context here. In the similar way, we are going to create another function here, sample 60%, where it actually takes 60% or whatever the group, what are the elements. For example, the students which have A grade, I have 3 elements, or let's say 10 elements. So it will take 60% of those values. Then it means that it will take 6 elements out of those 10 values. And let's say one data has 5, one group has like B has like 5 students. In that case, it will take 3 elements out of it. So we have defined a fixed fraction of that thing, or a fixed value that we want to take 60% of the data from that specific group. So in order to do that, I'm going to define a function named sample 60%. This will take the input, the group, individual group that we are actually passing it. Then it will return group sample. It will return the sample that is randomly selected, but with the fraction of 60%, that we are taking only the 60% of the elements. And once we have done that, we are going to apply the same methodology here, group df dot apply, and then passing the function as an input argument. So we have for such that so every this function is applied to every individual group here. Let me run this block of code for you here. Once I have done that, let me just print those values for you so you can actually see how the difference between disproportionate sample and proportionate sample. So for for disproportionate sample, where we define that we only want to take 2 values out of every element. So you can see that we have for A we have 2 values, for B we have 2 values, for C we have 2 values. And for proportionate sample, we tell that we only want to take the 60% of the data. In that case, A has 3 values, B has 2 values, and C has only 1 value. So that's the difference between those stratified sampling. That's how you actually do stratified sampling, by using Panda data frame group by object, and then you can define your analogy how you actually want to extract values out of the specific group element. So now let's move on and actually discuss about another advanced technique. This is called cluster sampling. So cluster sampling involves dividing the population into clusters or groups, then randomly selecting entire clusters to be included in the samples. Okay, let me repeat that again. Cluster sampling involves dividing the population into clusters or groups, then randomly selecting entire cluster or to be included in the sample. It is useful when the population is naturally grouped. Okay. So we are going to learn and we are going to exercise this concept by the help of Python programming. So that's where I'm going to teach you right now. So in order to make clusters, for example, let's know we have to actually make clusters. Then from those clusters we will actually sample values out of that cluster. Okay, so first of all I'm going to initialize a variable clusters, and I'm going to pass it as an empty list here. You can see that by using this Python statement. Once I have done that, what I'm going to do, I'm going to iterate on the population data we have actually defined earlier. If you recall that in the beginning of the lecture, we have actually created randomly 10,000 values that lies between 1 to 9. So this is the population data. Now I'm going to iterate over this population data with a range such that it will start with 0 and it will go towards the end of this population data, the length that is the 10,000, but it will go in an interval of 100. Okay, so it will go in an interval of 100. Okay, so that's what it means by and at each iteration we are going to extract that specific chunk of data from this population data. And how we are actually going to do that? It's quite simple to do. For every iteration, for example, you understand that we are applying a for loop. It starts with 0 and then it goes towards the end of the population data. The length of the population data, which in our case is 10,000, but it goes at an interval of 100 values. Okay, and how we are going to extract how we are going to make the clusters out of that population data? It's quite easy to do. We will declare initialize a variable cluster that will change its value at each iteration, okay, based on the index that is currently present in for loop. Then we are using this variable population data, and within the population data I'm applying the sizing method where this values will start with I index, then it will end at I plus 100 index. Okay, for example, if I values are currently at 0, it will start with 0, then it will end at 0 plus 100. It means 0 to 100. So in Python the ending index is exclusive, so it will be the range, then the index will be from 0 to 99. So it will take those values and it will create a list of those values and store in cluster. So once you have done that for the I is equal to 0, what it will do, it will append this cluster into clusters here, where it is different, like we have an S here. Okay, the one we have actually initialized earlier. So you will append those value to it. Then the I value will change through y from 0 to the next value, and then you will create another cluster and then it stores it in a cluster. So in that case the clusters will be a list of lists, where each list within that cluster is actually the sliced data that we get out of population data. Okay, that's how we are going to apply for loop and cluster the data. Now you have the clusters of data. What we are going to do, we are going to take sample. Okay, we are discussing about cluster sampling here. So in that case I'm going to first initialize a variable called sample clusters, and I'm going to assign an empty list to it. And what I'm going to do is actually I'm going to iterate towards the clusters we have actually formed earlier that are stored in this variable clusters. So I will iterate again within those clusters. Remember, the cluster is a list of lists, where each list actually represents a specific cluster from the population data we have extracted. So I'm going to extract again, iterate again on clusters for cluster in clusters. For each cluster, what I'm going to do is I'm going to use this NumPy library method that actually extracts randomly and based on the number of size we actually define. So for that purpose I'm going to initialize a variable named sample underscore elements. Then I'm calling the NumPy library and I'm calling its method choice, and within the choice I'm passing two input arguments. The first one is actually the current cluster that is being iterated from the clusters with S, and then a second input argument is actually passing the size of the list or elements we want. So it means that it defines that out of this cluster how many elements you want to extract randomly. In our case, we are only interested in extracting only 2 values out of it randomly. So once we have extracted that values randomly from a given cluster, what I'm going to do, I'm going to append that list of 2 randomly selected values to sample clusters here. So it will iterate our each cluster within the clusters, and it will extract randomly 2 elements from that cluster, and it append to this list here we have initialized earlier, sampled clusters. So after it had iterated our each cluster, what will do, I will use NumPy library, and I'm going to use this method concatenate that will actually convert all those list within a list to a single list, where a single list will have all those elements without going to list in a list. So I'm going to use this method concatenate, and it will concatenate all those values into a single list. Finally, I'm going to print that cluster sample list here. Now you can see that the cluster sample has been cluster sampling has been successfully done. So that's how you can actually do a number of sampling techniques by the use of help of Python programming. That's it for this tutorial. If you have any questions regarding this tutorial, then I request you to write down your questions in the comment section. I will be happy to help you out and answer your queries. And stay tuned. I request you to subscribe to my channel and hit the notification bell icon button, because I will be posting more videos about statistical analysis in Python that are like regression analysis, correlation plots, and even more in the future, where we actually implement the whole portfolio project for you, so you can actually learn from that portfolio project and use it and add it into your resume. Thank you for joining me, and I will catch you soon in the next video.